Okay, today we're going to be learning about the distributive property. So first let's start with what the word distribute means. Distribute means to give one to each. If I were going to distribute a piece of paper, I would give one piece of paper to each person in the classroom. So to multiply a sum or difference by a number, we're going to multiply each term inside the parentheses by the number that is outside the parentheses. All right, so that means that we're going to take the number outside the parentheses and multiply it by each number inside the parentheses. So we can multiply a times b and add to a times c. With numbers, we're going to multiply 5 times 6 and add that to 5 times 8. So let's try it using the order of operations and then same problems using the distributive property to show you why it works. So if we were going to use the order of operations, we know parentheses is first, which means we would add and then we would multiply. 4 plus 2 is 8 and 4 times 8 is 32. If we were going to use the distributive property to do the same problem, we'd do 4 times 6 and add that to 4 times 2, which is going to be, of course, 24 plus 8, which is 32. Notice we got the same answer. Let's try another example. We have order of options, 8 plus 5 is 13, and 13 times 2 is 26. If we did the distributive property, we'd multiply the number out the parentheses times each number in parentheses and add them together. So 2 times 8, 2 times 5 would be 16 plus 10, which is also 26. So again, using the distributive property or the order of operations gives us the same answer. Let's try one more example using the order of operations. I would do parentheses first and then multiply last to give 15, or I can do 5 times 10 and 5 times negative 7, right? Because I know you've heard me say this a lot of times, but the symbol goes with the number that it's right in front of. So we're going to treat that as a negative 7. And so we have 50 plus negative 35. Which, guess what, is also 15. So one of the things to remember, and you'll hear me say it again and again and again and again, is that the symbol in front of number goes with that number. We're making that a negative 7 so that we do our scoreboard. I know I have 50 positives and 35 negatives, so my answer is positive 15. That's one of the things that you really need to start to practice, because as you go farther in math, and you go on to algebra and beyond, those negatives get in your way if you don't learn them the right way now. So be thinking about that. Okay, so now this says to simplify, not solve. And we're going to be starting to use variables. Variables, as you know, are letters that represent numbers. And when we simplify, much like you saw when we did exponents, if you're in accelerated math, we don't always get an answer. We might just leave it in the simplest possible form, which is what's going to happen here. So we're going to do 4 times the first term, which is just m, and 4 times the 5, and we're going to add them. So the best we can have is 4m 20. That's the simplest version we can have as our answer. We cannot add 4m to 20 because one has an m and one is a constant term, and we can only add m terms to m terms and constants to constants, so we have to leave them like that. It's like if we had 4 monkeys and $20, you can't add that together and have 24 monkey dollars, right? That's the best we can do. So in this we have 9 times a, and then we have 9 times negative 6. 9 times negative 6 is negative 54, and we just leave it like that because we can't add 9 apples and then take $54 from 9 apples. It doesn't make any sense, so we have to keep them separate. And then lastly, we have 0.5x, and then we have the negative 12, 0.5 also. Of course, we know that 0.5 is, so half of negative 12 is negative 6, and these are my answers. So it's a little uncomfortable at first to not answer like 5 or something. We have to leave x terms and constants separate, a terms and constants separate. All right, and then lastly, it says to use the distributive property to solve these mentally. So what can we do to get 22 here? We can add 2 to 20. So then to solve that mentally, it's easy to do 20 times 8 is 160, and it's easy to do 2 times 8, 16, and then we easily have 106 without getting a calculator out or anything. I used the distributive property. So in that way, I could make this like 13, and instead of 39, I could 40 minus 1. And look how easy it is to do in my head. 13 times 4 is pretty easy to do in your head. You'd get 52 and then add that 0 because it's 40. And subtract 13. And look how quickly I was able to do this problem without getting out a calculator using the distributive property. And let's try 2 more. Here I have 75 times 40. Wouldn't it be easy if I changed that 75 to 70 plus 5? And then 40 times 70 is easy because we know 4 times 7 is 28. I just need a couple more zeros. And I know 40 times 5 is 200. And then look how easily I got 3,000. And lastly, I'm going to make this 100 plus 4. I know 7 times 100 is 700. And then 7 times 4 is 28, so this would give me 728. So I didn't use a calculator on any problem, but I am going to check right now my calculator and make sure I didn't make any mistakes before I turn this video off. Because you know I'm only human, so far everything is looking good. 75 times 40 is actually 3,000, and 104 times 7 is 728. So all of these are right. Yay, us. All right, that's the end of our notes, so you can go ahead and get these glued into your notebook. And thank you for watching.